Have you ever really thought about the water you drink? I mean, really thought about where it came from? Today we're diving deep into one of the greatest mysteries of our planet, the origin of our oceans. It's a cosmic detective story, and we're about to follow the clues.
You've seen this picture 1,000 times, right? Earth, our home. This beautiful blue marble just hanging there in the vastness of space. And the reason it's blue? Water. 70% of our world is covered in it. It's so fundamental to us, we barely even think about it.
But here's where it gets weird. Our planet shouldn't be a water world. When it was born, it was a hot, fiery, rocky mess. Way too hot for any liquid water to stick around. So that creates this huge contradiction. If we started out bone dry, how on earth did we get these massive, life-giving oceans? That's the case we're cracking today.
So here's our game plan. First, we'll lay out the mystery of our waterlogged planet. Then we'll investigate our first big suspect, water that came from space. After that, we'll look for clues of a hidden water source right here on Earth. We'll also figure out why the oceans are salty. And finally, we'll see how all that ancient water is still on the move today.
All right, let's start with the big paradox. How does a planet born in fire end up, drenched? This isn't just a fun question, it's one of the most important puzzles in all of planetary science.
I want you to picture this. Wind the clock back 4.5 billion years. The neighborhood where Earth was forming was chaotic and fiery. Our planet was basically a molten ball of rock, sizzling at over 1,000 degrees. Any water that might have been around would have just vanished, instantly boiled off into space. So the key takeaway here is Earth started its life completely dry.
So if the water wasn't here to begin with, it had to have arrived later, right? After things cooled down. This idea points us to some very specific suspects, visitors from the cold, dark edges of the solar system.
Okay, let's meet suspect number 1, icy travelers from deep space. The theory here is that Earth's water was basically a special delivery from the cosmos. And who were these delivery guys? Well, the prime suspects are comets and asteroids. You can think of comets as these giant, dirty snowballs just packed with ice and dust. Asteroids can carry a surprising amount of water ice, too. The idea is that for millions of years, the young Earth was pummeled by these things in a period called the Late Heavy Bombardment. They'd slam into the planet and deposit all their water, bit by bit, until the oceans filled up. It's a pretty dramatic story, but how could we ever prove it? Well, this is where the real detective work begins. We use a chemical fingerprint. See, not all water is exactly the same. Some water has a slightly heavier type of hydrogen, called deuterium. And the ratio of this heavy hydrogen to normal hydrogen acts like a unique signature, a kind of birth certificate that tells you where in the solar system that water came from. All of our oceans on Earth have the exact same fingerprint. So the logic is simple. If comets brought us our water, their fingerprint should match ours.
And this is where the case took a fascinating twist. Scientists sent probes out, like one that flew right through the tail of Halley's Comet, and they tested its water. The result? It was a near miss. The comet water had way more heavy hydrogen than our ocean water. It was close, but it was definitely not a match. This was a huge deal. It meant that comets, at least comets like Halley's, couldn't have been the main source of our water.
Now, this didn't close the case entirely. Some asteroids actually have a much closer fingerprint match, but it did mean that cosmic delivery couldn't be the whole story. So a new question popped up. What if the water wasn't a visitor? What if it was an inside job?
Time to investigate our second suspect. This theory says Earth was actually born with its water, but it was locked away deep inside the planet. For the longest time, this was just an idea. And then, one tiny, little crystal changed absolutely everything.
This quote is based on the analysis of a zircon crystal, a tiny geological time capsule found in Australia. And when scientists looked at this specific crystal, they found the smoking gun.
This little crystal was dated to be an incredible 4.4 billion years old. Let that number sink in for a second. 4.4 billion. That is almost as old as the planet itself.
To really get how mind-blowing that is, this timeline shows it perfectly. Earth forms about 4.54 billion years ago. This crystal shows up just 140 million years later, and the chemistry proves it could only have formed in liquid water. This was a bombshell. It meant our planet had oceans far, far earlier than anyone ever thought.
So how is that even possible if the surface was a hot mess? Well, there are two fantastic theories. One is that the very rocks and dust that built Earth had water molecules trapped inside them.
As the planet's core heated up, this water was essentially cooked out and blasted to the surface as steam from volcanoes, eventually raining down to form oceans. The other idea is just brilliant. A scientist got it from watching condensation form on a cold glass. What if dust grains in space just collected a layer of water vapor that then got baked right into the planet as it formed?
Okay, so the current thinking is that our water is a mix of cosmic deliveries and a homegrown supply. But all that original water was fresh. So where did the salt come from?
It's this super slow but relentless process. It all starts with rain. Rainwater is a little bit acidic, and when it falls on rocks, it slowly dissolves them, releasing salts and minerals. Rivers then act like these giant conveyor belts, carrying all those dissolved salts down to the ocean. Then, the sun does its thing, evaporating the water. But it leaves the salt behind. Do that for a few billion years, and you get some pretty salty oceans.
And it's not just rivers doing all the work. You've also got hydrothermal vents and volcanoes on the ocean floor, and they're constantly pumping out a rich mix of minerals and salts directly into the water, seasoning the seas from below.
And this brings our whole story right back to the present day, because the journey of that ancient, cosmic, salty water, it never, ever stops. When you look at all the water on our planet, the numbers are pretty humbling. A whopping 97% of it is salt water. That leaves just a tiny 3% as fresh water for everything else. But it gets even more dramatic when you zoom in on that little 3%. Almost 70% of our fresh water is locked away as ice. Another 30% is underground. That means all the lakes and rivers we rely on, that's just 1% of the fresh water. It really puts into perspective how precious it is. And every single drop, whether it's in an ocean, a glacier, or your tap, is part of the same grand, continuous system, the water cycle. It's the engine that's been recycling the planet's original water supply for billions of years, evaporating, forming clouds, raining down, and flowing back to the sea over and over again.
So the next time you take a drink of water, just pause for a second. The water in that glass has been on an unbelievable journey. Some of it might have hitched a ride on an asteroid. Some of it might have been trapped inside a rock for 1 billion years. It's almost certain it once fell as rain on dinosaurs. It's an ancient cosmic traveler. And its journey is far from over. Makes you wonder, doesn't it? What will its next chapter be?